Hello everyone, welcome to Equal To, and this is the 12th episode of our Polynomials playlist, and in this video we are going to solve a couple of example questions. Okay, we are starting with example 9. In the previous video we solved a factorized problem using factor theorem, right? This is going to be similar to that, but the thing is that in the previous question that wasn't a really good example for factor theorem, so it took a very long time for you to solve it. Okay, but in this case it's going to be quite simpler and it will probably get you familiarized with the factor theorem method a lot more better. Okay, so let me just rewrite the polynomial, or let me just read the question for you first. So factorize y squared minus 5y plus 6 using factor theorem. So this is your question, and the polynomial that we have is y squared minus 5y plus 6, right? That is right. Okay, now by factor theorem we know that this can be, let this be p of x, right? Let p of x is equal to y squared minus 5y plus 6. Okay, this is p of x. Now if this were to be p of x, then you can say that p of x is equal to x minus a into x minus b, where a comma b are zeros. A comma b are zeros of, I'm sorry, that went there. Okay, a comma b are zeros of p of x. Okay, if a comma b are zeros of p of x, then x minus a times x minus b is in fact equal to p of x. Okay, so this we know by factor theorem. Now with that you can tell that a b is going to be your constant. Okay, because if you multiply this, the only term that is not going to have x or x squared is going to be ab. That is the constant term, right? And the constant term in this polynomial is 6. So ab is going to be 6. Now what you are going to do is you are going to find the factors of 6. What are the factors of 6? 1 obviously is a factor of 6 and 1 is a factor of every number. Okay, and then 2 is a factor of 6. Okay, 2 times 3 is 6, so 2 is a factor of 6, and 3 is also a factor of 6. 3 times 2 is 6, so 3 is a factor of 6. Okay, so these 3 are factors of 6. Okay, now what you're going to do is, now these are factors of 6, but they can be positive or negative when they are going to be zeros of p of x. Okay, they can be both positive or negative, because two negative numbers, their product would also be a positive number. Two positive numbers, product would also be a positive number. So if you find one zero to be positive, the other should be positive for sure, and if you find one zero to be negative, the other should be negative for sure. Okay, so now what you are going to do is you are going to apply these values p of x, and they are going to see if that is a 0, right? So what is p of 1? P of 1 is 1 squared minus 5 into 1 plus 6. Okay, so that is equal to 1 minus 5 plus 6, so that basically is 2, right? So this is definitely not a 0. Okay, now you don't have to erase this in your papers, I'm just erasing it to make space. P of minus 1, that also can be another number, right? So p of minus 1 is here obviously 1, and minus 5 into minus 1 is going to be plus 5, and we have plus 6 here. So this obviously is not equal to 0, all positive numbers. So this also is not a 0. And then we have p of 2. P of 2 is equal to 2 squared is 4, minus 5 times 2 is 10 plus 6. Okay, so that is 4 minus 10, that is going to be minus 6, minus 6 plus 6, that is equal to 0. Since p of 2 is 0, x minus 2 is a factor. This we know by factor theorem. X minus 2 is a factor, and you're going to find other such factor for this polynomial. Now for that, what you're going to do, you're just going to repeat the process again. We know that minus 1 and plus 1 are not zeros. Plus 2 is a 0. We are going to check that for minus 2 as well. P of minus 2 is equal to, actually in this case minus 2 wouldn't be, because in the second term we have minus 5, right? So whatever you multiply a negative number with it, that would become a positive number. So here we have 4, and it becomes plus 10 and plus 6. So this obviously cannot be a 0. So minus 2 is not a valid option. And then we have P of 3. Okay, P of 3 is equal to 3 squared is 9 minus 5 times 3 is 15 plus 6, and that also adds up to 0. So x minus 3 is also a factor of this polynomial. Okay, both x minus 2 and x minus 3 are factors of this polynomial. So the factorized answer for this polynomial is x minus 2 into x minus 3. Because this is a quadratic polynomial, so it can have only two zeros, and 2 and 3 are zeros. 2 and 3 are zeros of P of x. So x minus 2 and x minus 3 are the factors. So x minus 2 into x minus 3 is going to be the factorized form of this polynomial. Okay, so that is all. This is very simple. It's not complicated at all. Okay, so hope you understood this. So now we are moving to the next example, which is example number 10, and we are going to factorize x cube minus 23x squared plus 142 minus 120. Okay, so there is something that is different here, which is this is a polynomial of degree 3. Okay, so far we have factorized only polynomials of degree 2. This is a polynomial of degree 3. How are we going to do that? Okay, so this is not that different from that. So there is only one more step involved here that we'll learn now. Okay, so what you're going to do is, even if it is a cubic polynomial which is having degree 3, the constant term should be ABC, right? The constant term should be ABC, where A, B, C are zeros of this polynomial. Okay, this is by the same logic of factor theorem. So what you're going to do is you're going to find factors of 120 first. What are the factors of 120? 1 is a factor of 120, 2 is a factor of 120, 3 is a factor of 120, 4 is a factor, and it goes on. Okay, so many things. Now what you're going to do is you're going to check if one of these numbers are a zero of this polynomial. Okay, let us say P of x is equal to x cube minus 23x squared plus 142x minus 120. Okay, so that is P of x, and we are going to find P of 1 now. P of 1 is equal to 1 cube minus 23x squared, which is minus 23, plus 142 minus 120. Okay, so 1 minus 23 is minus 22, and minus 140 plus 142 minus 120. If you add these two negative numbers, you get minus 142, and we have plus 142. So that adds up to 0. Okay, so P of 1 is equal to 0. So what does that say? It says that x minus 1 is a factor. If P of 1 is 0, then x minus 1 is a factor. This is what factor theorem says, right? This is what we know already, so there is nothing for you to get confused here. So x minus 1 is a factor. Okay, now what you're going to do is, let me just erase few things from here. Now what you're going to do is, you can either divide this polynomial by x minus 1, which is quite difficult. I mean, it's not that easy. So what you're going to do is, you're going to try to take x minus 1 as a common factor out of this. Okay, so we are going to try and rearrange this polynomial. Okay, if you were to take x minus 1 from this polynomial, how would you rearrange this? Okay, so what I'm going to do is x cube minus 23x squared, and we have 142x and 120, right? If you were to take x minus 1 out of these two terms, then this 120 has to be taken out, right? Only then it would become 1. So what you can do is, you can split this 142 and write it as 22x plus 120x minus 120. So what we have done here is, if we were to take 120 out of this 120, only then it would become 1, right? And we have to have another x as well. So we have rewritten this 142x as 22x plus 120x. Okay, so in the next step, what you can do is x cube minus 23x squared plus 22x, and you're going to take 120 as a common factor from these two terms. So that leaves you with 120 into x minus 1. So you have taken 120 as a common term here out of these two terms. So that leaves you with 120 into x minus 1. Okay. Similarly, you are going to get x minus 1 from the other terms of this polynomial as well. Okay. So now this has become a single term, 120 into x minus 1, from which x minus 1 can be taken out as a common factor. Okay. We are not going to take it out as a common factor not just yet, because we have to make the other terms like that as well. Okay, so just like we did with 120, we have this 22x here. Okay, if 22x were to become 1, you have to take 22x out of it, right? So you are going to split this 23x and write it as minus x square minus 22x square plus 22, sorry, it's not 12, it's plus 22x plus 120 into x minus 1. Okay, now what this allows you to do is, you can take 22x out of these two terms, minus 22x to be precise. If you take minus 22x out of these two terms, that will leave you with x minus 1. Okay, so the basic objective for you is, you have to split this terms in a way that you can take x minus 1 as a common factor out of this. Okay, so that is the basic idea. So x cube minus x squared minus 22x, if you take that common as a common factor, then you are left with x minus 1. Because you are taking minus 22x, this term would become minus 1, and the next term has already been 120 into x minus 1. Okay, now we have two terms that are sorted. So we have x minus 1 here and x minus 1 here, and we are left with the other two terms, x cube and x squared. And if we simply take x squared out of it, okay, so that is when x squared would become 1, right? So if you take x squared as common, it would become x minus 1, and the rest that we have is 22x into x minus 1 plus 120 into x minus 1. Okay, now all three terms of this polynomial have x minus 1 as its common factor. So you can take that common factor out. So that will leave you with x square minus 22x plus 120. Okay, now what we have done is, we have split this cubic polynomial into a linear equation and a quadratic equation. Okay, so combined degree you get again as 3. Okay, so that is what you have done here. Now to further, like, we haven't factorized this completely because this is still a quadratic equation. So what you're going to do is, you're going to further factorize this. Now I'm just going to write this as a separate one here. So let me just draw a line. Okay, x squared minus 22x plus 120, right? X squared minus 22x plus 120. Now this you can use your I method, that is splitting the middle term method, to solve. So the product should be 120 and the sum should be 22. Okay, since the product should be 120, obvious and simple way that you can think is 10 into 12, that gives you 120, right? There can be so many other ways as well, like 2 into 60 and so many other ways, but 10 into 12 is a simple thing that comes to your mind directly first, and 10 into 12 is 120 and 10 plus 12 is 22. So 10 and 12 could be the numbers that can be used to split this middle term. So x squared minus 10x minus 12x plus 120. Okay, now from the first two terms you can take x as common, so that leaves you with x minus 10, and the second two terms you can take minus 12 as common, that leaves you with x minus 10. And let me just erase this, it's getting confusing. Okay, so from these you can take x minus 10 as a common factor, so that leaves you with x minus 12. So this quadratic equation factorized, is giving you x minus 10 into x minus 12. We already have x minus 1 here, so x minus 1 into x minus 10 into x minus 12, and that is the final factorized form of this cubic polynomial. Okay, so this is the answer to this question. So if you are given a cubic polynomial, you just first, using trial and error, you try to find 1 0 of that. With that you can further we can further divide it into a quadratic polynomial and that factor that you have found, right? When you are arrived with a quadratic polynomial, you can further factorize it easily using your splitting the middle term method or the factorization method. Okay, so that is how you factorize a cubic polynomial. I hope you understood this. If you have any questions, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.